In this video, I'll be talking to you about EMC VNX's FAST VP, which is an acronym for Fully Automated Storage Tiering for Virtual Pools. Here's the agenda. We'll start with a feature overview, then I'll give you an explanation on how it works. We'll do a demo of FAST VP using Unisphere, and we'll finish with the benefits of FAST VP along with additional resources. Storage provisioning can be repetitive and time-consuming, and when estimations are calculated incorrectly, it can produce unexpected results. Matching performance requirements with frequency of data usage is not an easy task for storage administrators, and even when a match is achieved, requirements change, and a storage system's provisioning requires constant adjustments. To address this issue, EMC implemented FAST VP. This feature can both lower total cost of ownership, TCO, and increase performance by intelligently managing data placement according to activity level. It puts several different types of disks into an automatically managed storage pool. LANs use the storage capacity needed from the pool on the devices with the required performance characteristics. With this, FAST VP lets a single LAN leverage the advantages of flash, SAS, and near-LAN SAS drives at the same time. Tiering at the sub-LAN level moves more active data to faster drives and less active data to slower drives. In most cases, the less active data can be moved from the highest available storage tier without users noticing the difference. The value of FAST VP is based upon its ability to drive as much of the highly accessed data components onto the highest tiers of storage, such as flash, while optimizing for TCO by driving low-access data to high-capacity near-LAN SAS drives. It achieves this with a number of mechanisms. The first one is statistics collection. One slice of data is hotter, more activity, or colder, less activity than another based on relative activity level on those slices. Activity level is determined simply by counting the number of IOs, reads and writes, bound for each slice. FAST maintains a cumulative I/O count and weights each I/O by how recently it arrived. This weight deteriorates over time. New I/O is given full weight. After approximately 24 hours, the same I/O will carry only about half weight. Over time, the relative weight continues to go down. Statistics collection happens continuously in the background on all pool LANs. Now let's talk about the analysis cycle. Once per hour, the collected data is analyzed. This analysis produces a rank ordering of each slice within the pool. The ranking progresses from the hottest slices to the coldest. This ranking is relative to the pool, and a hot slice in one pool may be called by another pool's ranking. Statistics collection and analysis have no impact on host I/O and consume minimal CPU resources. The user can influence the ranking of a LAN and its component slices by changing the default policy from star hidden auto tier to either auto tier, highest, or lowest tier preferred, in which case the tiering policy will take precedence over activity level. Let's talk about relocation. During user-defined relocation windows, 1 gig slices are promoted according to the rank ordering performed in the analysis stage. During relocation, FAST VP will prioritize relocating slices to higher tiers. Slices are only relocated to lower tiers if the space they occupy is required for a higher priority slice. In this way, FAST VP attempts to ensure the maximum utility from the highest tiers of storage. As data is added to the pool, it is initially distributed according to the tiering policy selected during LAN creation. 10% space is maintained in each of the tiers to absorb new allocations that are defined as highest available tier between relocation cycles. Lower tier spindles are used as capacity demand grows. Now let's move to our demo. We'll start by launching Unisphere and navigating to the dashboard of the VNX system. Now let's create a pool. We go to Storage, Storage Pools, and then we hit Create. As you can see, drives are divided into tiers based on their performance characteristics. Currently, three tiers are being used: extreme performance, performance, and capacity. Users will now have the ability to select RAID protection according to tier. During pool creation, you can choose the appropriate RAID type according to drive type. Keep in mind that each tier has a single RAID type, and once the RAID configuration is set for that tier in the pool, you cannot change it. Another RAID enhancement is the addition of two more RAID configurations: RAID 5 8+1 and RAID 6 14+2 can now be chosen. Let's name our storage pool Mixed RAID. Now we click OK. And as you can see, our mixed RAID pool is now fully initialized. Let's view the properties of this pool by right-clicking the pool and then selecting the Properties option. One of the first things you see in the General tab is that both RAID type and disk type are shown as mixed. So let's go to our Tiering tab. This tab has two sections: the tier status and the tier details. The tier status section of the window shows FAST VP relocation information specific to our pool. As you can see, the auto tiering option is set to schedule. The move down and move up figures represent the amount of data that will be relocated in the next schedule window, followed by the total amount of time needed to complete the relocation. The tier details section displays the data distribution per tier. This panel shows all tiers of storage residing in the pool. Each tier then displays the free, allocated, and total capacities, the amount of data to move down and up, the amount of data to move within a tier, and RAID configuration per tier. In this case, we have the three tiers: extreme performance, performance, and capacity. We're going to move this data down 59 gigabytes, up 58 gigabytes, and we're going to do all this relocation in approximately half an hour. In addition to relocating slices across tiers based on relative slice temperature, FAST VP can now also relocate slices within a tier. Some disks within a tier may be heavily used, while other disks in the same tier may be underused. To improve performance, data slices may be relocated within a tier to balance the load. This new capability is referred to as load balancing and occurs within the standard relocation window. Let's click in the relocation schedule. In here, we can see that relocations occur every 24 hours for a duration of 8 hours. You can select the days, the start time, and the duration on which the relocation schedule should run. In this example, relocations run 7 days a week, which is the default setting. From this status window, you can also control the data relocation rate. The default rate is set to medium in order to avoid significant impact to host I/O. EMC recommends to set the relocation window either at high rate and run shorter windows, typically off peak hours, or low rate and run during production time. Let's continue our demo. For the purpose of this exercise, I have already created a LAN and I already assigned it to our mixed RAID pool. So let's take a look at the properties of our LAN. We click in Properties, and the tiering policy for this LAN is Start High then Auto Tier. Start High then Auto Tier is the new default policy for all pool LANs upon their creation. Initial data placement is on the highest available tier, and subsequently data will be moved according to activity level. This tiering policy maximizes initial performance and takes full advantage of the most expensive and fastest drives in your environment. Users also have the option of selecting other policies, such as Auto Tier, Highest Available Tier, Lowest Available Tier, and No Data Movement. Let's also clarify that when there is a pool with multiple tiers, the star hidden auto tier design is capable of relocating data to the highest available tier regardless of the drive type combination, flash, SAS, or nearline SAS drives. Also, when expanding a pool or adding a new tier to a pool, the tiering policy remains the same and there is no need to manually change it. Now that we're talking about expanding pools, I think it's a good time to talk about rebalancing upon expansion. The sudden introduction of new empty disks causes a data imbalance. This imbalance is resolved by automating a one-time data relocation referred to as rebalancing. This rebalance relocates slices within the tier of storage that has been expanded. Rebalancing occurs both with and without FastVP enabler. Let's continue with the last part of our demo. VNX file can also use FastVP. I have already created a file system that resides in our mix pool. So let's look at the properties of it. We go to Storage, File Systems, we click in Properties. As you can see, there is a field for Advanced Data Services, and we see that the tiering policy is set to Auto Tier / Highest Available Tier, also known as star hide then Auto Tier. You can view these Advanced Data Services from the File view, but to change them, you must make the changes on the underlying LUN and then do a rescan of your storage from the Storage tab's task. Benefits of FastVP. FastVP reduces pre-provisioning tasks while still giving the user to selectively choose the desired tier for data where needed. FastVP reduces storage acquisition cost while improving performance. It aligns with EMC's green strategy, reducing storage space and power expenses, especially with nearline SAS, which allow for fewer larger drives. FastVP accommodates additional load and performance by ensuring that only the most active data is stored on higher performance drives. And as you will see in the future, FastVP continues to improve with each release, while at the same time maintaining a consistent user experience. For more information, please refer to EMC VNX FAST VP, a detailed review white paper on EMC Online support.